Blockchain Mastery University. So today I've got another exciting tutorial for you. It's going to be a DeFi tutorial on how to do automated yield farming as a developer to give you a competitive edge in the DeFi space that normal users don't have unless you have these technical skills that I teach you inside this program. That's one of the greatest things about being a blockchain developer. There's so many different ways to make money with it, or maybe maximize your money with it. You can get a job, become highly paid. You can become a freelancer. You can build your own apps that earn passive income on the side, and you can also do this to maximize your money that you already earned right with DeFi and find the best interest rates possible. Maybe your stable coins that you have sitting in your Ethereum wallets, etc., etc. So I'm gonna show you that today. And even if you decide not to lose your own money, which most people probably won't, it's still a great tutorial. It's gonna show you how DeFi works, how you can interact with DeFi protocols as a developer, because these are the in-demand skills that you need to know if you're gonna work in a job that's for blockchain. A lot of people are building DeFi apps right now, so it's great fundamentals to learn how to interact with smart contracts, how to build your own projects that do this. So let's cover a few important concepts before we get started. So first of all, if you're just brand new, what is DeFi? Well, it's decentralized finance, or DeFi for short. It's one of the biggest trends in the blockchain space right now. This is basically taking financial products that we have today, moving them over to the blockchain, things like savings, loans, derivatives, trading, and moving them over to the blockchain, and also creating new use cases we don't quite have in traditional financial markets. Okay, so one of the biggest kind of use cases for DeFi is something called liquidity mining or yield farming. Well, they're kind of two different things, but I'll tell you what I mean here. So basically, I've always said one of the killer use cases for blockchain technology the average person can understand is essentially competitive interest rates. So think about your bank, for example. My bank gets really low interest rates, like 0.5% interest or something like that, and you can get much higher returns than that on top of Ethereum. So with DeFi applications. So think about an app like Compound Finance, for example. So this is a DeFi app on top of Ethereum. It's powered by smart contracts that run on the blockchain. And this website here talks to those smart contracts. So Compound is a savings and lending app. It works a lot like a bank, but it's all automated. So the use case I'm talking about is think about a stable cryptocurrency like USDC, for example. This is a cryptocurrency that's pegged to the US dollar. Each USDC coin is always redeemable for $1. There's no volatility in this cryptocurrency price. So you could basically deposit USDC in this application and earn 9.97% interest. All right, that's pretty crazy. That's pretty nuts. I mean, most people don't get that on their passive investments in the first place. And you're definitely not going to get that with your dollars sitting in your bank account. Okay, so this is a pretty killer use case for blockchain technology. I think the average Joe can understand. Okay, because a lot of them are looking at the interest they're earning in their savings accounts and saying like, hey, like. This is nothing, and then this is a lot more. So that means I'm not telling you to go liquidate your bank accounts and then put everything into DeFi. That's not what I'm saying. But I do think this is a really solid use case long term that can gain much wider adoption than it has today. So I just want to illustrate that. What does it mean for to earn high yield? Well, this is how you do it with an app like Compound Finance. But yield farming is essentially where people look at the yield, and this is yield, this is yield, this is yield, this is yield, and says where is my yield the highest? Okay, so you can look at an app like Compound, you get an app like Aave, okay, and you can see. Well, Compound's got 4.9% on DAI right now, and Aave, which is another app that does a very similar thing, has 7.3%. Okay, so they're going to say, all right, just from a very logical position, like where do I want to have my money parked right now? Well, if I'm holding DAI, there'd be a higher interest rate here, okay, inside of Aave. So maybe I might withdraw my DAI from Compound and move it over to Aave, okay? And for USDC, 9.31%, well, it's 9.97, so I want to keep my USDC inside of Compound, for example, okay? Now, if you were going to do this yourself, you have to sit here and watch these markets all day, okay? You might have to have your MetaMask vault installed and withdraw your tokens and then put them over here, et cetera, et cetera, et cetera. That's essentially rebalancing, right? You're rebalancing where your cryptocurrency goes. And, that would be a very active task. And in many cases, it might not be worth your time to sit here and check the markets all day if you're talking about a very small amount of money. Let's say you had $100 in these applications and you're just trying to maximize the yield and you spent all day, watching what these things are doing and trying to find where the best yield was. Well, that would not be a very efficient use of your time because the returns that you would get in terms of actual dollars for that, you'd be making pennies per hour, if that, to even watch that for that small amount of money. Now, checking a huge amount of money, maybe that's a different story, but for most people, small amount of money, it doesn't make a difference. So there have been DeFi apps that solve this problem. Essentially, like Yearn Finance is a good example. So what people call Wi-Fi. Okay, so I'll show you that. So Yearn is basically automates a lot of this. So you can see the Yearn V1 here. This is a DApp that automates a lot of that on the back end. It gets it with smart contracts. It finds the best deal for you. But you can also do some of this as a developer. Okay, and that's what I want to show you today. Is how to create your own scripts that essentially look at these different DeFi applications and find the best deal. So this is going to teach you how to interact with these DeFi smart contracts, which I think is really important. You're trying to build your own apps. You could take this example and go beyond the use case I'm showing you today. There's lots of things you can do with DeFi. We call them money Legos for a reason because the limit really is your imagination about what you can do with these different applications. You can plug them together, come up with strategies and recipes. I'm going to show you that today as a developer, but for this very specific use case on how you can find the best yield, deposit, and withdraw your cryptocurrencies to these applications. And the benefit here is the time savings where you can automate this process and say, okay, I just want to rebalance my portfolio automatically behind the scenes. All right. Now, of course, right now with Ethereum gas fees being what they are, some of this will be a little bit impractical because of the, it'd be expensive to change positions a lot of times because of the gas fees. But this is still great learning material to see how this works, get you started, and it will work a lot better as the gas fees on ETH improve, especially with layer 2 scaling solutions coming online relatively soon in the grand scheme of things. Okay. So let's look when we need to get started. So go ahead and download the code. There should be a link down below where you can download this. You won't have the GitHub link because it's a private repository, but you just have a zip file. We'll walk through these instructions here. Okay. So first, you want to find wherever you downloaded the code and open it in your terminal like this. And then you want to install your dependencies with npm like this. So npm install. So I'm personally using node version, let's see here, 12.10.0. So you'll want to do that too. You can always see which node version you have by going node-v. Okay, you can change versions with by either downloading a new version or you can use something like in to switch versions quickly. Okay, so we'll let these finish. Let's go ahead and look at the next things. So while you're getting ready, you'll need access to an Ethereum provider because we're going to actually make a copy of the mainnet. Okay, so we've been doing this in some of the previous tutorials, but I will, I'll reiterate this. Okay, basically, we need access to an Ethereum node in order to code against the main Ethereum network. So you can use something like Infura. Go to infura.io, click sign up, go to the dashboard, and create a new project, and actually get access to your mainnet Ethereum node. That's what it is. You run an Ethereum node, it gives you a link. I'll just show you. It's okay. We'll probably delete these projects later anyway. But basically, you'll do a new project. You'll click on this project. You'll see a link that looks like. It doesn't really matter. Like, let's see here. It's bad practice for me to show you this, but I can just delete this project later if I have to. Basically, you'll see a project looks like this. Okay, you'll copy this like this, and then you will go to your project. So don't use mine, but some people probably will. So I'll just delete the project later. And we'll use it to actually spin up access to Ethereum node for our development environment. So let me explain what I mean by that. just going to paste this here for later for safekeeping. Go ahead and keep your URL handy. So why we need this? Well, we're doing something called Ganache CLI, okay, to actually do this. Okay, so I'll show you why. I did a video about this in the video vault recently, but I'll refresh you. You can go back and look at that particular video to get a better understanding of this. I'll show you exactly what I'm talking about here. Basically, we're going to get a copy of the Ethereum blockchain locally so that we can code against it. So if you see this video right here, how to code real-world DeFi projects with Ganache hard fork, watch this video for a recap on the full explanation on this. But essentially what we're going to do is run a local blockchain, that is a copy of the main Ethereum blockchain. So we'll say ETH mainnet. We're essentially going to fork the Ethereum mainnet, the state, and we're going to unlock all the capability of this. We're going to pause it, we're going to freeze it in time and code against it so that we can have access to all the accounts, all the apps on this blockchain without having to risk any real cryptocurrency. Because if you're going to build this app, of course what you could do is you could basically take these smart contracts and put them on the Ethereum mainnet, all right, and then pay your own money to run this stuff and actually move the money around and pay the gas fees. You could definitely test it that way, but that's expensive, and I don't really want people to have to waste money doing that type of thing. So what we're going to do is get access to all the apps that are actually on the Ethereum mainnet with a local blockchain and run this, because that's what you need. If we're going to code against DeFi apps, then we have to actually access those smart contracts, their state, their behavior, all that kind of stuff on the actual Ethereum mainnet. So we're going to use Ganache CLI for this. So again, go back and check out that video if you haven't seen exactly how that works. But you can install Ganache CLI. I want your other package installed like this, npm-i-g Ganache CLI. Again, these instructions will be inside of your README file inside of your project here. So now we're going to actually start Ganache CLI with that Inferior URL. So I've got my Inferior URL here. So I'll do Ganache-CLI-P 7545 and then -f, and then we put in our node URL here. So what it's going to do is start up the blockchain forked off of the mainnet, and that's what the -f option is here. Okay. So now we have our blockchain running. We have everything installed. I'm going to open the code and show you what we're going to do here. All right, so our code here is just a set of scripts. Okay, this is a Truffle project. So if you've done any other tutorials in this program, Truffle is the smart contract development framework. We don't have actually any smart contract code that we're creating ourselves in this tutorial. We're just writing scripts against the Ethereum network. So we have a really bare bones Truffle project that has this Truffle configuration file. Okay, this just connects to our development blockchain we have running here, port 7545, which is just our copy of the Ethereum mainnet. So the cool thing about this is we have access to all these accounts in here for free, okay? And these accounts, we can act on behalf of any of these, okay? We can use their private keys, we have their address, and each of these start with 100 fake Ether, okay? So what we're going to do is actually create an app where we start with the, we begin with the starting point that's given to us, so which is an account with 100 ETH, okay? 100 ETH here, and that's our starting point, right? We have an account that has 100 ETH in it, and we have, an Ethereum mainnet with all these apps on it, right? We've got, Uniswap. We've got Compound. We've got Aave. All right. So how do we get to the point where we're actually earning yield on stablecoins? Well, we can take the ETH that we have. We can swap it on Uniswap for stablecoins. All right. So that the price doesn't change. And then we can look at the interest rates on different apps like Compound and Aave. Okay. And then we can basically say, okay, deposit some funds into here and then check the interest rates. If the interest rates are different, then we can rebalance to a new app here. So that's how it works. Basically, it's a multi-step process. We start off with an account with Ether. Okay. We want to start yield farming with stablecoins. So we have to go to Uniswap to get stablecoins. And then once we get the stablecoins, we'll deposit them into an app, and then we'll monitor the interest rates. And if the interest rates look favorable somewhere else, we'll change. And if not, we'll stay where we are. Okay. So that's going to be multiple scripts we have in our app that do this. That's the whole benefit, is we're maximizing the return on our stablecoins in this case. So we can see the scripts here. First one is get DAI. All right, so you can see this in our instructions here. So this is the first step. So what does it do? Well, we have a library file here that basically wires up all of these smart contracts that's required for this particular project. So whenever you're interacting with smart contracts on the Ethereum blockchain, you need two pieces of information. Because ultimately what we're going to do, we're doing these scripts in JavaScript, so we need to get we need to get a JavaScript version of the smart contracts we can call the functions in our own environment. Okay. So in order to do that, we're going to use a library called Web3.js. Web3.js just lets us, talk to Ethereum inside of JavaScript. We can create JavaScript versions of the smart contracts in order to call their functions, etc., etc. And in order to get a JavaScript version, we need two pieces of information. We need an ABI, which is this file right here. Okay, this is just a JSON description of all the functions inside the smart contract. The events, what type of arguments the functions take, etc., etc. It essentially just defines the interface. Okay, and then we need the address. So this is the location of the smart contract on the network. So this tells us how it works, and this tells us the exact address of it on the network, so we can create a JavaScript version of it. So we do that for every single player involved. So Uniswap, Compound, Aave, Uniswap, DAI, right? This is the stablecoin that we're going to swap for. So we need the DAI ABI and address. It's a cryptocurrency. It's an ERC20 token. It's powered by smart contracts. So we need the DAI ABI for the smart contract, the DAI address for the smart contract. Same thing for Aave. So Aave, again, is a DeFi protocol powered by smart contracts. So we get the important information here for Aave. And then the same thing for Compound. It's a DeFi application with different smart contracts. And we get the important information here and store those. Okay. And then we have a little bit of helpers here that we use when we swap on Uniswap. So the first script is about this first step in the equation where we have an account with ETH, but we want to get a stablecoin DAI to deposit for yield farming. So we swap it on Uniswap first. So we get the Uniswap information and the DAI information, and we basically create a JavaScript version of the DAI smart contract and a JavaScript version of the Uniswap contract using their address and their API, just like this, with Web3.js. So Web3 ETH contract, we pass in that information. Okay. Then we fetch all the accounts from our wallet here in Ganache. Okay. And then we also get the address for WETH. This is wrapped Ether. So all this is just, you don't have to worry about necessarily all the details about what's happening here. We're just preparing all the arguments that we need for Uniswap to make a swap. So this is the final function call here. So this is where we do the swap. So Uniswap swap ETH for exact tokens. This is the exact function call that you use whenever you make a trade on Uniswap. Again, we have a video about this inside the video vault. You can go check that out to see how to use Uniswap version 2. We explain that more in depth. But inside of here, this is essentially just how you do a function call for Uniswap to actually trade tokens. In this case, this particular type of swap, which is swap ETH for exact tokens. So token amount, two-string pair, right? And so there you go. We do a swap here. So now we can go to our terminal. Go ahead and run that. We can run a script like this. Let's go clear out this file. You can find this in your README. Okay, so I'm going to just do this. Looks like there's a typo here. It's a truffle. All right, so there's another typo here, so I just fixed that. Scripts. So there's a typos in the README. Sorry about that. All right, with this finish, and there we go. So DAI balance after swap is now 1,986. Awesome. So we have successfully swapped 1 ETH for DAI. Okay, you can see that here. All right. Yep, very cool. So now we've completed this first item list. We've swapped ETH for DAI. And now what we want to do is deposit this DAI into these DeFi protocols. So you can see we imported all of the important information from our library here. I'll explain all these one by one, but basically, DAI, Aave, and compound information. So basically how it works whenever you supply DAI to these applications like Compound or Aave, you give them DAI and they give you their version of Compound back. So like C DAI, C tokens. C tokens are interest-bearing tokens. And you just redeem those later and they determine how long you've held those for and they'll pay you out your interest. Same thing for Aave. If I give them, DAI, they'll give me back an A token, which is an interest-bearing Aave version of DAI. And then whenever I redeem it, they'll calculate the amount of interest that they owe me and they'll just pay back. So yeah, that's what we do here. We set these contracts up for DAI, C DAI like I just said, A DAI like I just said, Aave version 2, which is the actual protocol, and the Aave data provider. Okay, these are just JavaScript versions of the smart contracts that are required for this computation, or this script here, and we import the pieces to do that. We set it up here. Now we can basically check the DAI APY, okay, and then check the Aave APY. So basically we're just checking the current interest rates, okay, and then here's what's pretty cool. We say if the Aave DAI APY is greater than the comp APY, then we use Aave. If not, we use compound. So basically, here's a conditional. The conditional is in program. It just says if this, then do this, else do this. So essentially, we are at a fork in the road. This is how our script's intelligent and actually helps us make more money. This is the really important part. We say, hey, if there's a better opportunity here, essentially, if the interest rate's greater, use this. If the interest rate's greater here, then do this. Okay, that's the really important part. And you can see how simple this is with the program. You just basically say, you check the APYs. I realize this is like multiple lines. If you're a new programmer, this can be a little daunting. But here's the important part. It's really simple to check. You just say, hey, if it's better, then do this. If not, then do this. Okay. And so you can read through this and see exactly how this is calculated. You can also go check the documentation here and see this. All right. But that's what it does. It just checks which one's better, and then if this one's better, it deposits into this, and you can see the balances at the end. So run the script here. Say truffle exec scripts. You can do tab completion here and say 1 deposit. So 1 deposit script and see which one it chooses. All right. There we go. So we can see it's very intelligent. It checked the supply APY on compound. It was 4.9% for DAI, and it was 7% on Aave. Okay. And so now it's saying I'd rather use Aave because the supply is higher, or the interest rate's higher. And now whenever you do that, you see that the A DAI balance is 1,986 because you deposit on Aave, you got A tokens back, which are just interest-bearing versions of DAI. And then for compound, you don't have anything. So you can see that here. You can see this live on the website. So 7.3%. And then, let's see how long it takes. 4.9%. And you can see, yep, that's the exact values you see here in your application. So last thing we want to do is rebalance. So here's a script that you can run constantly, basically. Now, I say constantly. You wouldn't really want to run this constantly because the gas fees on Ethereum right now without layer 2 would basically make you probably lose money long-term with this strategy. But basically what you would do here is run this script continuously, or maybe some sort of intelligent interval, let's say like once per day, maybe once per hour, whatever it is. As fast as you want to monitor the interest rates, that's what you do. So basically what it does is it does the exact same thing as the last script. It checks the, it checks the APYs, but then it rebalances. So essentially if one's higher than the other, then it will withdraw from one and go to the other. So basically, like if you've already done this and you're in compound and you see that the interest rate's higher on Aave, it takes your funds out of compound, moves to Aave, and vice versa. If you're in Aave right now and the interest rate's higher on compound, it withdraws your funds from Aave and moves over to compound. So you can see that here. We check the supply, we check the rates just like we did earlier, and then here's how you withdraw. You use the redeem method. Okay, so C DAI again. Whenever you deposit into compound, you get back. If you're depositing DAI, you get compound DAI. So C DAI is interest-bearing DAI. If you have C DAI, you just say redeem. So C DAI is the contract methods. Redeem your C DAI balance, which we calculated here, and then we send that, and then do comp controller methods. Claim comp, so you redeem first, and then claim comp. So that's the actual cryptocurrency. That's the extra bonus reward you get with compound cryptocurrency doing that. So yeah, you take your money out of compound this way, and then you move your money to Aave this way. Okay, so this is the exact same thing we did in the previous script, but this is how you withdraw. So we just withdraw and then move here. So conversely, if it's a different situation, then we do the exact opposite. You can see exactly how to do that here. Okay, so here's the withdrawal methods from Aave. Aave, A DAI, the token you got back once you deposited DAI, you approve it, and then because you're basically depositing an ERC20 token, and then you withdraw it that way, and it takes your A DAI out of your wallet and gives you back your DAI that you deposited originally, plus your interest, and then moves it to compound here. So we can run that. Click rebalance, and probably not a lot's going to change. Yep. So basically, it stayed the same. So the interest haven't changed. We could simulate a time where those interests are different. We could wait for interest to change in the blockchain. And when they do, it'll move over. And so you can run this script multiple times per day, all that kind of stuff. Okay. So that's how that works. And then lastly, you've got some homework here, which is to withdraw your funds completely. And I'll give you some hints. Here are the functions that we use to withdraw from compound. So this is how you get back your DAI. This is how you redeem your comp tokens that you got for bonus. And then for Aave, this is how you get back your DAI from Aave as well. Okay. So you could, with those hints, you could essentially implement a withdrawal script to take all your funds out of every single application that you've used in the process. Okay. So last final word of warning. Of course, this is risky stuff to do with large amounts of money on the real Ethereum network. You will definitely pay a lot of gas fees if you try to do this right now. Trying to rebalance your portfolio all the time will probably result in a net loss with the current state of Ethereum right now. That being said, we are moving to L2 relatively soon in the grand scheme of things that can make these types of strategies much more economically viable. So with that being said, hope you like this video. As always, you reach out in the chat if you have any questions. And until next time, thanks for watching Blockchain Mastery University.